modifies it. Yeah. So it's highly supported. On top of that, we use Heroku as our hosting platform. So Heroku have a fleet of Linux servers that they rent out to us. The great advantage of using Heroku is that we can scale up and down the number of servers that we have deployed at any moment in time. And Heroku offer us a lot of packages to connect to different data sources, which I'll jump into next. Yeah? So that's the big advantage. It saves us having to spend a lot of time on things like DevOps, which is managing our server fleet. So we're essentially outsourcing the management of our server fleet to Heroku. We will want to change this at some point, probably use a fleet of our own servers, using something like Docker. But I don't think we're quite at that stage yet. We might want to do that in future to provide heterogeneity. And all that means is that we don't really want to use servers all in one place, provided by one person, because if that one entity is targeted, if they're singled out, we want some kind of resilience, right? So we want to be able to spread those things out, and we want the customer to not know or care. We just want requests to come into us, and for us to balance that out across a fleet. Yeah, we're not quite at that scale yet. Cool. On top of Heroku, we have a web server. Our web server is called Puma. So web servers come in different flavors, but the job of a web server is to take a request from your web browser, figure out what you need, and send it to you. Yeah. So if you send a particular URL to the web server will figure out what to send you back. Yeah. Good. So we use Puma because it's very lightweight, and the most important thing with a web server is you need to be able to respond to things quickly. Right? You don't want one that's sitting there for ages. There are two different ways that you can go with this. You can use servers that focus heavily on memory usage or focus heavily on CPU performance. So we go for ones that are heavy on the CPU performance. Why do we do that? Because compute cycles are cheaper than memory. So you can get a faster computer cheaper than you can get one with more memory. Yeah, simple. On top of that, our data store is called PostgreSQL. So it is in essence what's called a SQL database. Yeah. You've got different flavors of this. So you've got MySQL, you've probably heard of that. Big proponents of that, Facebook. Facebook have done a lot of customization to MySQL. And Postgres, so Uber was using Postgres until 2014, at which point they switched to one they developed in-house. Yeah. Good. So we're probably going to be using Postgres for some time, but there are other types of databases called NoSQL databases that we're likely to start using sometime soon. So a SQL database is a relational database. All that separates these two is that if you think of just data, there are a couple of ways that you could store that. You could just have a bucket in which you dump everything, and you have to go and find it. Or you can start storing data as connected to other bits of data, like an agency has multiple offices, an office has multiple properties. Those are relations between entities. Yeah? And you can kind of see the advantages of one or the other. I mean, a relational database lets you have a clear structure between entities. Whereas if you just wanted to take, say, the pool of emails that were sent in and just throw them in a big box, you'd probably want a NoSQL database for that. Yeah. So what we're doing governs the data source that we use. On top of that, the language that the web server, that the backend is built in is Ruby. So common point of confusion between people, the difference between a language and a framework. So a framework is built in a language. Languages are things like Ruby, Python, Java, C#. And a framework is a bunch of tools that people have built in that language to achieve a job faster. So a lot of people will be using Ruby, and someone will create something like a web framework in Ruby that will handle a lot of the common tasks that you would need to do when building a web app. Yeah? There are lots of different frameworks. We chose Rails because it's widely supported. There's a huge community. There's lots of things called gems, which are pre-built packages of code that do various bits of functionality. Saves us having to do a lot of that. So for example, even down to our authentication system, we didn't build the login, we used somebody else's. Yeah, good. And that is it. Next up is the front-end stack, which Jinder is intimately familiar with. So, front-end, back-end, how do they talk to each other? You're familiar with HTTP, you've seen it in all of the URLs that you've ever typed in. So HTTP, Hypertext Transfer Protocol being the operative part, it is the mechanism by which data is sent from the front end to the back end. Yeah? It just means how is data encoded and sent. And then there are loads of ways that you can send that. So you could just send text plain, or you could send it in a prearranged structure, and the structure that we use is called JSON. Yeah, it's just a particular way of writing it so that the backend understands it. Great, good. The front-end stack, a lot simpler. So HTML, which is the bare bones structure of the web page, the elements themselves that you see, a button, a table, something like that. On top of that, you've got CSS, which governs how it looks. So that is the color of the button, particular style of the font, things like that. We use JavaScript to provide interactivity. So I'm sure you've been to web pages where they don't do very much. They're quite static. The only way to interact with them is through hyperlinks, which is you click one and you go to a different page. You click one, page loads and goes to a different page. We use JavaScript so that the website behaves much more like an app. You don't really see those page reloads. We pull in bits of a page rather than the entire page. Yeah? And then the framework that we use is called AngularJS, which is built by Google. Yeah. So another widely supported one, and we went for that for a similar reason. Yeah? So that is the full whirlwind tour of our two tech stacks and how they talk to each other. Any thoughts, questions?
You could ask at all.
Super easy.
I have a question.
Yeah, shoot.
So for all the language that you're speaking about, is there like one that's the most simple? Is there one that's the most complicated, or are they all kind of the same? It's just that, or one that